Welcome to The Explainer. Today, we're diving into something really cool. We're going to trace the fascinating evolution of tech automation. We'll follow the path from the cognitive brains of modern AI all the way down to the highly scaled, rigorous testing ecosystems we actually need to keep those AI systems in check. It's this continuous loop of thinking, acting, and validating, and it is literally reshaping how software is built. Let's get right into it.
Here is a quick look at our roadmap. We're starting with generative AI fundamentals, moving into Agentic AI and the Loop, touching on APIs and context protocols, and then wrapping up with automated testing using Playwright and scaling it all with performance engineering.
All right, let's kick things off with Section 1, Generative AI Fundamentals.
I want to anchor our entire discussion on this one powerful insight from our source material. Listen to this. Generative AI gives machines the ability to create. Agentic AI gives them the ability to act. That distinction is absolutely crucial. It's one thing to have a machine that can, write a poem or generate a block of code, but it's an entirely different, much more powerful ballgame when that machine can take real-world action based on what it just created.
To put that into perspective, look at the sharp contrast between the old guard and the new frontier. Traditional AI is essentially a highly advanced sorter. It classifies things from fixed categories using clearly labeled datasets. Think of your standard email spam filter, right? But generative AI fundamentally flips the script. It doesn't just categorize, it composes entirely new outputs. And it does this not by understanding the way we do, but by learning complex statistical patterns from massive amounts of data and sampling from those probability distributions. So, how do we get from just generating things to actually doing things? That brings us to Section 2. Agentic AI and the Loop.
This is where the real magic happens. We are moving completely away from single-turn question answering. No more just asking a chatbot a question and waiting for a static reply. Agentic AI refers to systems powered by large language models that can autonomously plan, reason, and take actions to hit broader goals. We are shifting from a reactive system to a proactive agent. It doesn't just talk, it acts.
And it does this through what's called the Agentic Loop. It's a continuous, step-by-step cycle. First, the agent perceives, gathering inputs from its environment. Then, it thinks, using the LLM to reason about the absolute best next step. Next, it acts, executing that chosen action like firing off a search request. Finally, it observes, recording the result, parsing the data, and updating its memory. Then, the whole loop starts all over again until the goal is fully achieved.
But to actually execute actions in the real world, these agents need virtual hands. Let's look at Section 3, APIs and context protocols.
Before an autonomous agent can do anything, it needs an interface. Think of an API like a waiter at a restaurant. You are the AI agent, the kitchen is the database, and the API takes your order to the back and brings your food out. It's just a defined set of rules exposing back-end functionality over HTTP. Basically, APIs are the bridges that allow completely different software systems to seamlessly talk to each other.
When an agent decides to interact with data, it relies on 4 basic operations known as CRUD: create, read, update, and delete. This is basically the day in the life of a data request. The agent translates these operations into specific HTTP methods. It uses POST to create data, DET to read it, PUT or patch to update it, and delete to wipe it out. And when the server replies with a 200 OK or a 201 created status, the agent knows its action actually worked.
Now, to safely bridge the AI's reasoning engine with these APIs, the industry uses tools like the Model Context Protocol, or MCP. What's amazing here is how MCP acts as a highly secure translator. It can expose complex database servers like Postgres, allowing the AI to safely run SQL queries. It also exposes web and API servers, giving models like Claude native built-in access to browse the web or pull analytics from platforms like GitHub. It essentially hands the AI direct, secure keys to the world's data. Now, with agents running loose making changes, we need a robust immune system. Let's jump into Section 4, automated testing with Playwright. When AI agents rely on web interfaces, those interfaces absolutely cannot break. Playwright is a hugely popular Microsoft-developed open-source framework built exactly for this: end-to-end testing and web automation. What makes it a real game-changer is its isolated browser context model. Basically, it spins up a completely fresh, isolated environment for every single test, kind of like popping open a brand new incognito window each time. This ensures data doesn't leak between test runs and your web environment is rigorously validated. And just look at the sheer versatility here. Playwright doesn't lock you into one ecosystem.
It supports multiple languages: JavaScript, TypeScript, Python, Java, C#. Plus, it lets you test across all major modern browser engines like Chromium, Firefox, and WebKit. And you do all of that through one single API. It's just a fantastic, comprehensive safety net.
Look, if you've ever dealt with automated testing, you know the absolute nightmare of flaky tests. Playwright has a feature called AutoWait that completely removes that headache by waiting for web elements to be fully visible and ready before trying to interact with them. It also offers network interception, so you can easily mock those APIs we talked about. Combine that with a rich trace viewer for deep debugging, and Playwright becomes the perfect defense mechanism to make sure your UI is rock solid.
Finally, Section 5, Scaling with Performance Engineering.
Because here's the reality. Having a fully functional web app is completely pointless if it crashes under the weight of thousands of automated agents hitting it at once. Performance engineering cannot be an afterthought. It has to be woven into every single phase of the software development lifecycle. You start by defining your requirements and SLAs on day one. Then you move into API profiling during development. Hit full stride with dedicated testing cycles and continue straight into production with constant monitoring. It's a proactive, nonstop discipline.
Notice how we deliberately escalate the intensity here to hunt down hidden weaknesses. We start with a standard load test just to check the system under normal expected traffic, but then we push harder. A stress test cranks up the load to find the exact breaking point. A soak test runs for hours or even days to sniff out slow memory leaks. And a spike test simulates a sudden, massive surge in traffic. We break the system on purpose so it doesn't break when real users or real AI agents are relying on it.
And to measure if we're actually surviving all this, we rely on some very strict metrics. We have SLAs, which are our external, contractual promises to clients regarding uptime and speed. But to guarantee we actually hit those, we use SLOs, service level objectives. These are our internal targets, and they are intentionally much stricter. If the contract says a 2-second response time, our internal SLO will demand 500 milliseconds. It builds in a crucial safety buffer.
Which brings us to the ultimate question we all have to ask ourselves. We are rapidly moving from AI that just types out text to AI agents that continuously perceive, think, and act on our digital infrastructure. As these autonomous agents start executing API calls and manipulating databases at massive scale, are your functional and performance testing frameworks genuinely robust enough to keep them in check? It's something to think about. Thanks so much for joining me on this explainer.